Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 2 of the Hoffer book, 7th edition, and Chapter 2 is entitled The Origins of Software. The learning objectives I'm going to allow you to read for yourselves. And by way of introduction, the landscape of software that's available to the organization today is extensive and varied. And this is really in contrast to the way things were when I got into the business. I've been in the business for 40 years, so I've seen a lot of changes. The change in available software has really kind of changed the role of IT people and systems analysts in particular in reaction to the various opportunities that are available. So in this chapter, we're trying to get you up to speed on all the possible sources of software, and then and to discuss, wherever possible, what those implications are for your role as a systems analyst. Okay? Here we're talking about application software. So organizations use lots of kinds of software. They use operating systems. They use kind of basic end user productivity applications like email and calendaring and all those kinds of things. And for the most part, those things are just the platform on which we build custom solutions that help us to solve the problems and capitalize on the opportunities within the business. Okay, so we as a systems analysts are going to take that stuff as a given, and we're going to be working with people on how to solve really bigger problems, more the customized problems that relate to particular requirements in the business that our organization is engaged in. And when I say business here, I don't mean for profit only. So I have quite a few students in my various courses who are involved in libraries and museums and academic research data centers and archives and all kinds of things that are not for profit, classic kinds of business. But when we say business here, what we mean is the business of whatever you're doing. So there are some processes, there are a lot of records that need to be kept, and we mean business in that sense. Okay? So there are so many sources of software these days that we're no longer at the point where we need to build it all ourselves. So the third bullet point here, much of in-house coding involves making components work together. This approach is called systems integration, and it recognizes that we're not going to build everything ourselves. Some things we're going to build, some things we're going to buy, and some things are going to be hybrids of things that we build and things that we buy. And that what we ought to be thinking about is, what are the criteria going to be on which we're going to evaluate software that we're going to choose, because the systems analyst will be looked to make recommendations whenever the organization is going to buy software from the outside. So there's a lot of talk in the chapter about outsourcing, and maybe a little more than I think is than I want to give airtime to. But what is outsourcing? Well, turning over responsibility for some or all of an organization's information systems, applications, and operations to an outside firm. So what kind of outsourcing goes on? Well, two examples here on slide 5. Shell Oil outsource spending in 2008 was $3.2 billion. Shell's outsourcing vendors included EDS, T-Systems, AT&T, IBM, Logica, Wipro, and Accenture. And since then, I would say that EDS has been bought by HP, I believe, and probably sold again, but things change. Reasons to outsource: cost effectiveness, taking advantage of economies of scale, making up for lack of in-house knowledge, freeing up internal resources. A lot of times when you see people who are making the pitch for organizations to buy their IT from the outside, which is something that I did for years when I was in the business, you try to convince the organization that they have certain things that are their competitive advantage. And maybe that's not going to be IT. Maybe their competitive advantage is going to be, typically the way that they understand their customers and the way they understand their products and their services. But maybe how they support all that with IT is not particularly what they want to compete on. So they want to free up their internal money and time for things that they feel that they're going to be competing on, are going to be more important in terms of beating their competitors. You might want to reduce time to market. You might want to increase process efficiencies. And then the last one, the system development is not a core activity for the organization. We have other core activities. Okay, so that's outsourcing generally. And generally when we talk about outsourcing, we're talking about having somebody either provide a system to us or provide a system and the people who support it. There are even outsourcing vendors who provide the system, the people who support the system, and then the users who operate the business. Okay, that's an extreme form, but there are people who do that. Okay, so let's talk about the sources of software. And not all the services that go with them. So, I guess information technology services firms could provide software and a bunch of other services that complement them. Packaged software producers tend to produce application software of various kinds. And sometimes they will also do some customization or tailoring of it for a particular customer. Enterprise-wide solutions, we have these so-called ERP systems, enterprise resource planning systems, that are a cadre. They're a collection of application systems that at least in theory, will cover your organization from soup to nuts. So in the corporate for-profit business world, the classic enterprise-wide solution is an ERP like PeopleSoft or SAP. Okay. In the library world, we have a number of vendors who provide a suite of applications that solve the problems of the library. Okay, so that's more of an enterprise solution there, something like an ILS. Cloud computing. These are solutions that are available over the internet, probably where you don't install the software yourself, and it's run by the vendor in the cloud. Open source software, kind of equivalent to packaged software producers, but the software itself is free in some sense, in that you don't have to pay a licensing fee. And then you have to make the decisions about how to tailor it or customize it for your own organization. And of course, in-house developers, this is the classic make of the make or buy side. These are the people who are going to make either the whole thing or the parts that we're going to make ourselves as compared to the parts that we're going to buy. And here on slide 8 is just a picture version of the same thing. Slide 9 has some examples of those different kinds of organizations. So in IT services, they've got Accenture and HP, certainly big ones. Packaged software providers, Intuit and Symantec. Enterprise software solutions, Oracle and SAP. Cloud computing, Salesforce.com, open source, SourceForge.net. Okay. So now we talk about each of these in turn, or at least a couple of these in turn. So information technology services firms can help companies to develop custom information systems for internal use. So just because you're going to build it yourself doesn't mean that it has to be built by your people. You could have a vendor, some kind of IT services firm, come in and build it for you. So that's one possibility. Okay. Packaged software producers, they serve many market segments. Okay. And generally speaking, packaged software producers are either horizontally, they have a horizontal focus or a vertical focus. Now this isn't a term that the authors use, but it's been used in the industry for some time. So a horizontal focus would say that this is a software package company that has applications like, let's say, payroll, accounting, human resources, manufacturing stuff that is applicable to a number of industries. Okay, so and in a table that this horizontal and vertical comes from, the rows are the applications themselves: payroll, accounting, human resources. So companies who kind of offer that to a broad range of industries are sort of horizontally organized. And then there are some who really organize themselves to, according to these things, become called vertical markets, like car dealers, beauty salons, retailers. Okay. And typically in the tables that you see in which these things are organized, those industries are the columns, hence vertical software package producers. Okay. Now, some of these, there's another distinction, okay, and that is some of these things are pre-packaged in the sense that you can buy them ready-made, ready to turn on and go, okay? So there's a lot of software that we're used to seeing, things like software from Intuit or that kind of stuff, say accounting software that you plug in and you're pretty well ready to go. For larger organizations, things are not quite so easy. Typically, you have to at least populate all the accounts into them. There's no kind of default approach. So there's some amount of customization that has to go on. So those are maybe, they're packaged, but not as neatly packaged. Let's say that. Packaged software runs on all sizes of computers. Prepackaged software is off-the-shelf turnkey software, not customizable. So that's what they mean by prepackaged. Off-the-shelf software at best meets 70% of the organization's needs. So even if you go out and find something for your industry, you buy it from some kind of a vertical software package company that has something, has everything for your industry, you're probably only going to get maybe 70%, 80% of your needs met. The rest of them, you're going to have to, you're probably going to have to use some custom software. So the classic prepackaged software, here's a copy of the output from Microsoft Project. That is classic prepackaged software. It runs right out of the box. Enterprise solution planning systems, the classic one of those is the company SAP has a suite of applications that are part of their ERP system. Here we have a slide that I'm going to make a little bigger so we can read it. And let's see if we can pull it over here. There we go. Okay. So let's say if in fact you were to implement all of their modules, they have executive management support, financial management, customer relationship management, work, human resources management, supply chain management, project management, supplier relationship management, and compliance management. These people claim to have cradle to grave complete suites of applications. They would like you to believe that they can meet more than 80% of your need, and maybe they can if you're a particularly compliant organization. They also give the impression that these are highly integrated applications, like they all talk to each other. In reality, most of the ERP producers, they bought their products from more than one company, and they have had to integrate them, themselves. So the level of communication between the different modules is high for some and low for others. You can't just automatically assume by looking at this lovely slide that just because the slide looks like everything is very neatly integrated into one beautiful cooperative whole, that there are already implemented interfaces between the modules that you need interfaces between. Okay? So that looks pretty good. Let's make it a little smaller than that. Okay. Looks good. Cloud computing. The provision of computing resources, including applications over the internet, so customers do not have to invest in the computing infrastructure needed to run and maintain their resources. The classic example of this, I think, is Salesforce.com. Here you can give a group of applications to your Salesforce that will allow them to manage the sales process, and they just have to log on to the internet. And it's all hosted by Salesforce.com. So they talk here on slide 17 about Google Drive, which again is not much of an application to me. That's more of a utility. Microsoft Azure, again, that's more of a platform. Amazon.com is more of a platform. The only real application that I see here on slide number 17 that you could really get me excited about as a good example of using cloud computing to meet the application software needs of your organization would be Salesforce.com. The benefits, you free your internal IT staff, faster access to application than via internal development, i.e. you just turn it on, okay? Lower costs than internal development, at least for most organizations, it would cost them more to develop something like Salesforce.com for their sales staff than to buy the service. Concerns, security, reliability, and regulation compliance. Whenever you take your IT and you give it to another vendor, you are relying on their security and their reliability. Okay? In particular, the security is a regulatory compliance issue. So if Salesforce.com gets hacked, well, maybe somebody will find out what you're doing on the sales side. So maybe that's not such a, the end of the world. But let's say you have some e-commerce application that you run in the cloud, and it gets hacked, and they get the credit card numbers of all of your customers, as has happened in a number of situations. Well, that has both a security and a regulation compliance. It has those two dimensions. Open source software is becoming increasingly popular, and there's a lot of examples here. Now, they give 3 examples here, which again I don't think are good examples of open source applications. Examples: Linux is an operating system, MySQL is a database management system, and Firefox is a browser. These are not typically things that the systems analyst is asked to recommend, okay? But there are application solutions in a number of areas that are open source. And typically they work like this. There is a community open source version that's free, and then there's a paid for a proprietary version that has support and those kinds of things. And depending upon your taste for the level of service and the level of pay. You pick what you want. Okay. Things to be remembered about open source software is, of course, there are a lot of costs to software that are you're always going to have, regardless of whether you're paying a license fee for the software or not. So you're going to have to train your staff to support it. You're going to have to buy the hardware and the system software to run it. So a lot of people think of open source software as free, and of course, in terms of paying some kind of a one-time fee or annual fee for using the software, that's true. But of course, all the other costs apply. So when you look at the costs, you have to look at the complete, as we say, life cycle cost of that solution. In-house development, I mean, we've been doing this since the 1950s. If sufficient system development expertise with the chosen platform exists in-house, then some or all of the system can be developed by the organization's own staff. Hybrid solution involving some purchase and some in-house components are common. So this approach is called systems integration. Additionally, some organizations who are doing in-house development will bring in resources from the outside, consultants and contractors to make up for some of the positions that they're not able to staff themselves. So there are a lot of dimensions in which you can do things kind of inside and outside. A lot of flexibility. Okay, slide number 21 has a good rundown of the sources of software components, and I'm going to leave that for you to read. So here we come to a discussion of how to select off-the-shelf software. So off-the-shelf software is software from some kind of a packaged software company, either prepackaged, as I said, the shrink-wrapped stuff, which it typically is not modifiable, and the more high-end stuff that is modifiable. Okay, so what are the dimensions we're going to look at? Well, one is cost, of course. Comparing the cost of developing the same system in-house with the cost of purchasing or licensing the software package. Okay, so that's one dimension that you need to look at. Okay. Functionality. The tasks that the software can perform and the mandatory, essential, and desired system features. Now, this is a place where the systems analyst gets called in for consultation a lot when we're looking at potentially buying software or adopting open source software. Okay, and the work that we do in this course is going to allow us to document the requirements such that you could look at any potential off-the-shelf software system and say, to what extent does it meet the requirements that we've already documented? Functional requirements, requirements that have to do with features, and non-functional requirements that have to do with things like reliability, performance, those kinds of things. Okay, so this is an important area. This is the functionality. So this is the functional requirements. Right? Vendor support. Whether and how much support the vendor can provide and at what cost. Okay, because to the extent that we're using somebody else's software, at least in theory, we might know less about that software than the software that we wrote ourselves. So maybe we want to go to the vendor when we need help with it. And to the extent that we do, is it available and how much does it cost? The viability of the vendor. Can the vendor continue to adapt and update the software to changes in system software and hardware? Now, this is important for both private companies that have proprietary software and for open source projects. The proprietary companies, the question is, are they going to survive? If they're not going to survive, then you're eventually going to get to the point where you need to go to a new release of an operating system, and there's no vendor there to update the software so it'll work with the new release. Okay? The question is, in some situations, you don't even get the source code. So you don't even have the source code if you wanted to make those kind of changes yourself. A lot of software vendors of this kind have gotten rid of that problem of inaccessibility of the software, is that they have given their software to some kind of escrow agent, and should their company fold, their users are allowed to go to the escrow agent to get the software. But then, of course, you would have to do the update yourself. And the viability of an open source project is equally important because are the people going to be there for the next round of changes that have to come along? So, for instance, when I look at some kind of open source product, I want to know how recently has it been updated? Do they update this on a regular basis? How big is their installed base? Because I just, what I don't want to be is the last guy in the door, right? I'm the last guy in the door. It hasn't been changed for 3 years. And what? It's dying, and I got in when it was in the death throes. Well, that's not when you want to join in. Flexibility, the ease with which the software can be customized. Okay. In the face-to-face classes, I always pick a student and say, Tom, what do you think the salesman says when you ask him or her if the software can be easily customized? And they always kind of smile and they say yes. Well, of course they do. That's what salespeople say. So the fact is that whether the software can be easily changed and customized and adapted is really a technical question. So if in fact the salesperson says, no, it can't be changed, well, probably it can't be. But if they say yes, then you need to get some technical people looking at it and to see what capabilities they have for customization and whether you concern how flexible you consider this to be. And documentation, of course, getting a system with no documentation or out-of-date documentation is probably worse than getting one with good, up-to-date documentation. Now we get to those non-functional requirements. Things like response time, ease of installation. Again, in our course, we're going to have you document both functional requirements and non-functional requirements. So if somebody were to say to you, how about this off-the-shelf software, should we get it or not? You ought to be able to compare your list of non-functional requirements to the attributes that the product has. Validating purchase software information. How do we find out the answers to the questions? Well, you can collect information from the vendor. If the vendor is not going to make a claim, then the claim probably cannot be made. Okay? Now, the vendor may make claims that cannot really be supported. You can look at software documentation. You can look at the marketing literature. You can do more. Okay? Two things that you can do that I think are really important. One, talk to customers who are using this, who are organizations like yours, and find out about their experience. Okay? Well, number one, find out how close to you they are. Okay? Are they the same size? Do they use the same features? All of those kinds of things. Are they using the same version of the product? And number two, find out how happy they are. What have they been happy about? What they've been unhappy about? And of course, a lot of times, vendors will want to give you a list of 2 or 3 people to call, and certainly call them. But I've been given people to call who were not happy, but those are rare and far between. So if you call the people they give you, they'll probably be happy. But the thing is, can you find other people other organizations who are like you, who are not happy, and why? Okay? And then the other thing is, if in fact you're buying something that's fairly big and you're spending a lot of money, you ought to be able to get your hands on the software for some kind of a trial or demo. That might cost you something to do, but actually getting your hands on the product and doing some kind of maybe proof of concept with it has a value to your organization. You're going to learn a whole lot from actually trying to install the product and to use it in some kind of a controlled way than you will from talking to lots of other people and from reading documentation. You might, if you were, especially if you were working for some kind of public entity and you were going out and you wanted to get some software to do something, you might actually issue a formal request for proposal, or RFP. An RFP is a document provided to vendors to ask them to propose hardware and system software that will meet requirements of a new system. And we say system software there, but we could mean, in this case, we've been talking about application software. There's a difference between an RFP and an RFQ. An RFQ request for a quote is typically a request for pricing on things that are highly specified and where there's no custom approach, whereas an RFP, a request for proposals, is a request for vendors to come back and to describe their unique approach and their pricing. Information sources for the RFP, the vendor's proposal, running software through a series of tests. Of course, you can do that whether you're going to have an RFP process or not. Feedback from other users of the vendor's product, talked about that already. Independent software testing services, that's always a possibility. Articles in trade publications. Now, the last thing we're going to talk about in the chapter is reuse, okay? One of the things that you're probably going to want to consider, one dimension that you're going to want to consider in terms of software that you get from the outside, is how reusable it is. And why is that important? Well, there are 2 things that can happen that you should be concerned about. Thing one is maybe you have another requirement in your own organization that's like the one that you're currently filling, okay? But it's a little different, all right? can you take all or part of the software that we have here? How adaptable is it? Okay. Kind of the other side of the same coin, what if things change in your business? Okay. How easily can you change the software? Now, basically, modern software that's either based on object-oriented development or component-based development, at least in theory, is going to be more reusable than old-style software that isn't based on either of those approaches. So when you're looking at alternatives, one of the things that you would probably want to rate your software on is how reusable the software is. And that's all I want to talk about that. That is it. Okay, so in terms of things that I want to emphasize for the chapter, I've talked about them. So I'm going to say bye until next time. Bye-bye.